Picture this, a crime scene. All the obvious clues have been bagged and tagged, but there's still this huge question just hanging in the air. What really happened here? You know, for centuries, that single question has fueled this relentless, incredible search for truth, a hunt for traces that are, more often than not, completely invisible.
It all boils down to this one fundamental idea, the bedrock of all forensic science, from a French pioneer named Edmond Lacard. Every contact leaves a trace. It sounds so simple, but it's incredibly powerful. It means a criminal always brings something into the scene and leaves with something from it. The real trick, of course, is finding it.
And that's the multi-million-dollar question, isn't it? I mean, how do you solve a crime when your best piece of evidence is a microscopic fiber, or a faint chemical stain, or maybe a hidden pattern you didn't even know to look for? Well, this is the story of how we learn to see the unseen.
Okay, so let's dive right in. And you might be thinking we're going to start in 19th century Paris, or maybe foggy London. But nope, we're actually traveling way back to Joseon-era Korea, where, believe it or not, a really advanced form of forensic science was already well underway.
They had this book called The Muwon-ruk. And get this, it wasn't just some dusty old suggestion manual. This and later books like Jang Yak-yong's Him Shinso were mandatory guides for officials. The whole point was to make sure there was a systematic, evidence-based process for justice. No guesswork.
Now, at first glance, a procedure like this might look a little like superstition, but it's actually pure chemistry. That silver hairpin, the yunbinyo, has a chemical reaction with things like sulfur or arsenic, which, back then, were common ingredients in poison. So that color change? That's not magic. That's a chemical test revealing a deadly secret.
And their powers of observation were just incredible. They understood a really basic biological fact. If you're alive and struggling in the water, you're going to instinctively gasp for air, and you're going to inhale water, sand, mud, whatever's around you. But a body that's thrown in the water after death, it would be clean on the inside. It's a fundamental distinction that forensic examiners still use today.
All right, let's jump forward in time to the 19th century. This is where the hunt for invisible traces zeroed in on something everybody carries with them, a unique signature that we leave behind with just a simple touch. This was, without a doubt, the fingerprint revolution.
You know, this wasn't a single eureka moment. It was more like a slow burn of discovery over decades. It all started with a Scottish doctor in Japan, Henry Faulds, who noticed these cool patterns left by ancient potters on their work. That little observation sparked an obsession, leading him to prove they could be used for identification. And then you have Francis Galton, who came along and mathematically proved that no two are alike. It was this step-by-step process that built one of the most powerful tools in law enforcement history.
The year is 1892. For decades, it's all been theory and research. But now, this revolutionary, kind of crazy idea of using a simple fingerprint to catch a murderer was about to be put to the ultimate test. And that test came in this absolutely heartbreaking case in Argentina. For the very first time in history, a fingerprint, an invisible trace made visible by blood, provided the absolute, undeniable proof that solved a horrific crime. The theory was now a fact. It worked.
So, from the unique swirls on our fingertips, the search for the invisible trace took another massive leap forward. This time, it went in two directions: inward, into the very code of life itself, our DNA, and into the complex, often hidden patterns of the criminal mind.
I mean, the 20th and 21st centuries just blew the doors wide open. Suddenly, investigators had this incredible new toolkit. We're talking DNA analysis that could identify someone from a single cell, criminal profiling that could build a picture of the person behind the crime, and so much more. Underwater forensics, polygraphs, digital trails, ballistics, the list goes on. And just look at this, the case of New York's Mad Bomber. The police were totally stumped for 16 years. So they bring in a psychiatrist, Dr. James Brussel, who just by analyzing the bomber's letters created this profile that was, well, it was unbelievably accurate. But here's the kicker. The detail everyone remembers. He predicted the guy would be wearing a buttoned-up, double-breasted suit when they found him. And when they arrested George Metesky, that is exactly what he had on. It was proof that you can find traces of a person in their psychology, not just at the scene.
But of course, the ultimate game changer was DNA. Using a process called PCR, which is basically like a biological photocopier, a lab could take one invisible skin cell left behind and multiply it millions of times.
Suddenly, they had enough to create a unique genetic profile, solving cold cases that were decades old, and just as importantly, proving the innocence of people who were wrongly convicted.
So, when you take a step back and look at this whole journey, right, from these ancient texts in Joseon, Korea, all the way to the high-tech labs we have today, what does it all tell us about this constant quest for the truth?
It tells us that while the tools, the technology, they're always evolving, always changing, the fundamental mission, that has never changed, not one bit. It has always been about making the invisible visible. It's about speaking for victims who can't speak for themselves and making absolutely sure that the truth, no matter how deeply it's buried, eventually comes to light. And that kind of leaves us with one final big thought to chew on. With every single technological leap we make, we get better and better at finding those tiny traces criminals leave behind. But here's the thing. As the science of detection evolves, so does the art of deception. This search for the invisible trace, well, it's the ultimate cat-and-mouse game, and it never ever truly ends.